This is the I'm not a good skier example problem. In this problem, an 83 kilogram skier starts from rest, skis down a hill with an angle of 30 degrees. The friction between himself and the ground is 75 newtons. The hill is 100 meters long. We're going to find the final velocity and the time when the skier reaches the bottom of the hill. Step 1, as always, is to draw our picture. So here's the picture. Here's the skier. Gravity parallel goes down the hill. Normal force is in the positive y direction. Friction is going back up the hill in the negative x direction. Gravity perpendicular is in the negative y direction. I wrote down all of the things that were given in the problem. The mass of the skier is 83 kilograms. Friction, 75 newtons. The skier starts from rest, so initial velocity is 0 meters per second. The displacement is 100 meters. That's how long the hill is. And we're looking for final velocity and time. In this particular problem, we're combining our forces things and our kinematics variables. Whenever we do this, we look to see what we're solving for, and in this case, it's kinematics variables. Since we're looking for kinematics variables, we're going to start in forces and find acceleration. So step 1 was drawing the picture. Step 2 was positives and negatives. That's already done. Step 3 is break anything that needs to be broken into components. This doesn't have any forces at weird angles except for gravity, and we already broke that into components with gravity parallel and perpendicular. So our first step is to find the acceleration of the skier as he goes down the hill. So setting up our force equation in the x direction, we're going to have force of gravity parallel minus the force of friction. That's going to equal the mass of our skier multiplied by his acceleration. We're trying to solve for acceleration, so rearranging the equation for that. It's force of gravity parallel minus the force of friction divided by the mass, and that equals the acceleration. Plugging in our numbers, the equation for gravity parallel is the sine of the angle, 30 degrees, times the mass of the skier, which is 83 kilograms, times 9.8 meters per second squared, minus the force of friction, which was given in the problem as 75 newtons. And we're going to divide that by the mass of the skier, which is 83 kilograms. All that will give us our acceleration. And when we plug into our calculator, we should get that 4 meters per second squared is the acceleration of the skier. From here, that will give us V naught, that will give us D, and A, and now we have to go back and solve a kinematics problem. We'll solve for VF first. We'll use the fourth kinematics equation, which is VF squared equals V naught squared plus 2AD. Solving for VF, that would give us VF equals the square root. V naught squared is 0, so that would just cancel out and go away, leaving me with 2 times acceleration, which is 4 meters per second squared, times d, which is 100 meters. Plugging in our calculator, we would find that the final velocity is 28.3 meters per second. Now we're going to solve for time. Solving for time, going to have a little bit of trouble finding some room here, but we'll do what we can. Using the third equation, d equals v naught t plus 1/2 at squared. Again, v naught is 0, so this term will cancel. When we rearrange for the time, we would get 2d over a, and it's the square root of that, for time. When we plug in our numbers, it would be 2 times 100 meters all over 4 meters per second squared. And after we plug that in our calculator, we get 7.07 seconds. So remember, when you're trying to find a kinematics variable in a forces problem, you start with your forces, find acceleration, and then use that in our old kinematics equations to solve for the variables that we're looking for, in this case, VF and T. And that's how you solve the I'm not a good skier problem.